Good morning, everyone. Shall we start? Okay, so we are slowly approaching the end of this course. You've just finished the second last peer review. Did everything go well? Maybe? And we've published the last assignment. So this is going to be assignment 6. The deadline is on the 4th of December. So again, you have 3 weeks to finish this assignment, and then there will be one last peer review. Let's just have a quick look. So assignment 6 will get you again 45 points maximum. So you can actually collect quite a few points in this assignment. So 15 bonus points for the bachelor students and 5 bonus points for the master students. And so here, for this assignment, you can actually pick and choose which assignment you want to do. So you can just do very few assignments if you don't need so many points, or you can choose more and more assignments if you want to make more. So there's no dedicated bonus assignments. You can just pick and choose the assignments that you want to do. Also, I should mention already now that in order to get the points for assignment 6, you also have to participate in the peer review of assignment 6. Because basically we want to avoid that people don't participate in the peer review for the last assignment anymore because they have already enough points. So it's just, in order to get all the points, you basically have to also do the peer review. But it shouldn't be too much effort, I think. I am aware that this is the beginning of December is you also have exams, right? So we should kind of keep it simple there. Okay, but if you quickly look through this, so we basically, the first task is to create a plotting script. Here you can use Matplotlib, for example. Then you create a visualization app using Flask. So this is this web framework that I've showed you last week. Then you make this framework interactive. So you add some buttons and some sliders to change the visualization. Again, this is the Flask techniques that I showed you last week. Then you can make it a bit more complex. So we're going to visualize the CO2 emissions by country in this case. And then you will create documentation and a helping page for that project, and that I will show you today. So there will be 2 projects, one called PyDoc and the other one called Sphinx. Both of them you can use to create documentations for your projects. And then the last one will be an exercise on predicting, so using the data, but not only kind of visualizing the existing data, but trying to predict what is going to happen in the future. And I will cover a little bit of this next week. Okay, and that's it. So there's some clarifications on the bottom. Okay? All right. So then let's move on to today's lecture. So today I will show you some of the common steps that I typically do when I move from a script that I've written at some point to maybe a more advanced software project. So maybe I've written something that turns out to be very useful, not just for me, but for other people, and I want to extend it, I want to make it more modularized, and I want to add maybe documentation and tests and so on. And I will guide you through the steps on an example project. So what are the typical steps that we perform when we move from a simple script to actually a software project? So the 6 points that I've added here, there are probably more, but these are, I would say, kind of the most typical ones. The first step that one does is we need to reorganize our script into modules and functions so that other people can reuse our code rather than just calling the initial script. The second step is that we add documentation. Right? So we already have, we've learned this and we practiced this over the past week, so we need to add doc strings so that people understand what our code does. What I haven't covered so far is step number 3. So ideally we would like to have some kind of project website with the documentation, with some kind of online documentation that explains how to use the code. So I'll show this today. Then another very important point is how we handle errors. So as soon as we give our script to other people or our project to other people, we also have to assume that people use it in a wrong way. So they type in random stuff and they call the functions in the wrong order and so on. So we need to make our project more robust and be able to handle errors in a way. So I'll show you how we can do this as well. Then the next step is to add tests. So we've already covered this a little bit with PyTests, but I'll show you an example again. And then finally, we should add some kind of installation instructions or installation files so that people know how to install our project. Okay. And the test case where I want to demonstrate this on is this game that we've developed last week. Remember, we had this. We had a Flask application that was very simple, where you played a game where you select one door, then the game host opens another door, and then you can choose if you want to change your mind and choose another door or stick to the original door. And so that was kind of a very simple script. So if you look at this directory structure of our little script that we wrote last time, is we had kind of one base directory where we stored everything. Then we had one Python file called gameserver.py. So we called that to start the server. And then we had a directory called templates where we stored all kind of HTML files that we needed to get everything up and running. And the way we would use it is that we go into that directory up here and then we call Python gameserver.py. But there was no documentation, no tests, and nothing. So one of the goals is to add all this. And another goal is also to make actually this project not just to make the game not just playable through a website, but also through a command line interface. And so the best way to do that, or a very common way to do this, is to code up the actual game part into a module, and then have a script that uses that module in a Flask environment, and another script that uses that module in a command line environment. So we kind of share the core module for both interfaces, both the command line interface and the web interface. Okay, so this is the first step is to reorganize our script such that we have a module, basically. I want to make a Monty Hall game module that we can reuse. And this is the directory structure that I came up with. So now, I've restructured our game a little bit. So we still have a main directory where all the files are contained. And then we have 3 subdirectories in here. One is called bin, and here I store all the scripts that the user can run. So in particular, I coded up 2 scripts here. I called it one script called play Monty Hall _CLI for command line interface.py. And if you run this, then it starts the game with the command line interface. There's another file called play Monty Hall _web.py, and if you call this, then it starts the web server and you can run it with a web interface. Then we still have our templates.html files. So these are all the templates that we need for the web server. And then this is the new thing here. So now I created a directory called Monty Hall _game. And so this is a module because I also have this file _init_.py. So as soon as we have this init file, we know that the directory is actually also Python module. And then there's the actual Python file. There's the actual module file called montyhallgame.py that contains all the code. So I can show you how let's have a look how this module directory looks like. So you can see in my current implementation here on the left, I have the bin, I have the Monty Hall game, and I have the templates folder. And so let's look at how the module is coded up. So the init file just imports the Monty Hall game class that I implement in this file, montyhallgame.py file. So the init file actually doesn't do very much. And really all the implementation is in this montyhallgame.py file. And so you can see I restructured, or rather than just kind of having a flat script, I now decided to make a class. So I wanted to have a class called Monty Hall Game that derives from a normal Python object class. And we can look, I don't want to go through the implementation in detail, but so one thing that I find really useful is whenever you create a class, or whenever you create a module file, at the end that you have kind of this if name equals main test that is only executed if you actually call the Python file directly, so not as a module file, not importing it as a module, but rather than just calling the Python file. And so in here, I typically just code up a simple example on how to use this class. So this is almost like documentation for myself, but also it allows me to just run it very quickly to see if everything still works. And so here you can see roughly how I intend to use this Monty Hall game class. So first, the idea is you first create a new game. Then once you created a game, you can select a door. So I'm the player, so you select a door. You select door number 1. And then you call this function letHost open door. And this actually returns a number that tells me which door the host opened. So this would be now a number either 2 or 3, but not 1 because this is the one that I selected. Then I can ask the game which are the available doors that I can now pick. So game.available doors will return me a list of doors that are not opened. So, and I make a random choice here. And then I select again a new door. So after the host has opened a door, I can select a door again. So either I choose the original one again, or I choose another one if I change my mind. And then I ask the game to actually open my door, and it returns me Boolean, which is either true if I won or false if I lost. So this is kind of the game that we've coded up before in this web interface in a more abstract format and written in a class. Yeah, and so if you look at the implementation, it's fairly straightforward. So for example, the init file creates a new game ID. So this is something that we had. This is something that might be useful if you just want to identify different games. And then we, as soon as we initialize a game, we also decide what is the winning door. And so this is interesting. So here I decided to actually, I don't want the programmer who uses my module, I don't want him to see or her to see the winning door. So I used this double underscore syntax here. And remember, the double underscore syntax is used if you want to hide variables. So this is going to be a class, an instant variable that is hidden, that you can't access directly when you type ipython dot and then double tap. This underscore winning door will not show up immediately. So, but there are ways on how to get around it. It's just this is kind of little trick how to make it more complicated to cheat. And then I initialize the selected door and the open door and the reselected door to all none because the user hasn't opened anything or selected anything. Yeah, and the rest is basically exactly the same implementation as last time. Maybe one interesting part here is these statistics. Remember when we wanted to kind of collect information about each game and then also print out some statistics. And the way I've implemented that is I created a class variable. So remember, a class variable is a variable that is not attached to a specific instance of an object, but it actually is shared between all instances. So it's something that belongs to the class, but not to one particular instance. And so the statistics of all the games is a typical example of that. So you compute the statistics not from an individual game, but you compute the statistics of all the games that have been played so far. And so this is why I create this stats variable here that is a class variable. And in my case, it's a dictionary that maps the string changed into actually another dictionary where I just count how often did you win when you changed and how often did you lose when you changed your mind. And similarly, I remember how often did you win when you didn't change and how often did you lose when you didn't change. Okay, so and this stats variable is being updated when we open the door. So it's this code up here when you open the door and we actually finish the game. This is also when I update the statistics. So I type in Monty Hall game.stats. So this is how I access the static variables. And if I change my mind and I won the game, then I increment the changed and won integer here, right? So this is the way how I treat the statistics. And then I created this function statistics, and now this again is a static method. So you can now call with this function implemented, you can call Monty Hall game dot statistics without having to instantiate an object. And that will compute the statistics and print out the string. Okay, so just a small reminder on how to do how to implement a class and how to implement a static method and static variables in a class. Okay, and so now once we have done this, we can go to, so I have all my files in here, and I can, for example, type in python bin playmontyhall.cli, which I haven't shown you yet, so maybe let's have a quick look here. So this is the command line interface, and so basically what this one does now is it imports my Monty Hall game class, and then it loops because I might want to play the game multiple times. I print out some welcome statements. Then I instantiate a new game. I ask the user to select a door between 1 and 3. So I use this input statement here to ask the user for a key input. And then I call game.selectDoor with the integer that the user has selected. Then I let the host open a door, tell the user which door was opened, print the available doors that the user can choose now, and ask for a new door. So here the player can decide if he wants to change or stick. Then select the new door and open the door, and then print some statement. Print if you've won or not. So yeah, let's try it out. So here's my command line interface. I'm being asked which door I want to select. I select door number 2. The host opens door number 3. So now I can choose between door number 1 and 2. So maybe I choose number 1, and I've won. And it actually prints me out the statistics straight away, and it starts a new game. So now I could play again. And so the same way is now the web interface uses exactly the same strategy, just that instead of having the command line interface, I just now use Flask. But you can see I use the same module here, and I use exactly the same functionality from the module. Okay, so with this structure, I now have kind of a shared module, and I can have multiple interfaces and actually it's very easy for me to just implement a new interface, because all I need to do is I need to import my Monty Hall game class and call the relevant methods on it. Okay. Step number 2 is to add docstrings. So the code that I've showed you so far was just code, and if it gets longer and more complicated, then very quickly I won't, or other people won't understand anymore what the code does. So the way we add documentation is by adding docstrings. So where do I actually want to add docstrings here? The most important function where I want to have docstrings is in the module file. So now in my new implementation, I've now added docstrings to all relevant parts of the code. So in particular, at the beginning, where after I define the class, I have a long docstrings that explains what does this class do. So it instances a new Monty Hall game object. And I also, this is something I typically like seeing, is if there's kind of example usage on how to use this class. Right? So I just copy and pasted the code that I had on the very bottom, the sample code, up here to tell the to have some documentation how to use the class. Another thing that I've added here is, so here for example is the static method with the statistics. So one important thing is that obviously you should always state what the function does, and you should also state what the arguments are, what the arguments mean that you pass into the function, and also what the function returns. And there's actually a special syntax for indicating what it returns, and also for the input parameters, and it's with this colon returns colon. And the string after this, it explains what the return value is. And so the reason why I've decided to have this specific format here is because our Sphinx documentation tool that I will show you in a second will actually understand this syntax here, and it will highlight the return values in a specific way. So let's look at another example. So here, the selectDoor function takes an argument door, which is an integer that is either 1, 2, or 3, so depending on the door that is selected. And so here, I used colon ivar door, colon, with a description afterwards, to indicate that this variable here, not named door, has the following meaning. And again, the Sphinx documentation tool will understand this and will highlight, or will create a nice documentation for this. Okay, so with this, I can now import my Monty Hall game class, and I can use this question mark syntax in IPython to ask for the documentation, and then I will get, for example, just for the class method, I will get a nice docstring with the example usage that I've implemented. And that hopefully will give users a good step forward to get started with the class. Okay, I think so far, up to now, everything was fairly standard. So now we not only want to, it would be nice to make this documentation actually available online, maybe as a web page. And there are basically two common ways how to do that. I will show you the built-in way first, and then I will show you a more advanced tool. So the built-in tool that Python comes with is called PyDoc. And PyDoc is a tool that automatically generates the documentation for a Python file. So you give it a Python file, and it generates the documentation for that specific Python file. So the advantage of that is that it's actually built into the Python software repository, so that you don't actually have to install anything to use it. And so the way you use it is that if you just want to create a text documentation for a Python file, you just type in pydoc and then the Python file. You can also ask it to create a HTML documentation of a Python file by typing in pydoc -w Python file. And it even comes with a little web server, so you can type in pydoc -b, and then you provide a port name to start the web server that actually lists all the documentation of all available modules that are on your system. So let's try this out on our little project. So I'm now, with this line down here, I'm calling pydoc -w, and then I'm giving it the file of the module that I've written, right? So let's try this. So the output is that it wrote a Monty Hall game.html, and then I can open this HTML file, and it opens a very ugly page consisting of the documentation of my file. So what do I have? It tells me that this file uses two modules. It depends on two modules, random and UUID. It contains some classes, so in particular this Monty Hall game class that we implement. And then we have various different, we have documentation for the actual class, including the example usage. And then we have all the methods that we've defined as part of this class. So these are for example, the available doors, the let host, open door, and select door. And then we also have one static method down here, which is this statistics method. Okay, and so, yeah, you can see that pydoc actually doesn't make use of these special commands here. So here it just says returns list of available doors. So there was kind of no syntax interpretation of the doc strings, which Sphinx does. But this is kind of a very easy way on how to create documentation for your project. Okay, then a more complicated one, or more advanced one, I should say, is called Sphinx. And so Sphinx is a package that it's a very powerful tool to create documentation and actually to create entire web pages. So I can show you an example. There's a project called Phoenix Project that I work on as part of my research. And this is a software package and the entire documentation here is created with Sphinx. So you can see there's it's a normal project web page. But the interesting part is that I can go here to documentation, and I can click on, for example, the quick programmer's reference for Python in this case. And if I click on here, I get a list of all the functions that are available as part of the software project. And I can click, for example, in function space, and now it will show me the documentation for that specific class. And you can see that it's very rich documentation. So this is not just text, but it's actually, we have tables down here, we have example usages down here, it's all highlighted, and I can I can click on things as references and so on and so forth. Okay, so this is what Sphinx can give you. So Sphinx does not come with the standard Python environment, so you need to install it. The way you install it is typically by using pip. So you just type in pip install Sphinx. And if you want to now, so by now nothing has happened, right? So there are basically 5 steps that we need to do in order to create the documentation for our software project using Sphinx. The first one is we type in this command Sphinx -quick start, and that will guide us through kind of the configuration steps of Sphinx for our project. So it will ask us various questions. For example, where do you want to store the documentation in your project folder, and things like that. I can show you that in a second. And then the second part is that we actually we need to specify which modules we want to see as part of the Sphinx documentation. And there's this command called Sphinx -API doc, and this it takes in an output directory, but it also takes a module directory. And what that does, it loads in the module and it automatically generates the documentation for all the objects for all the classes and all the functions in that module. So we will want to call this function here for our Monty Hall game module. And then we can edit so all the documentation in Sphinx is with Markdown files, and we can edit, for example, the index Markdown file. So this is the page that the user visits when he comes to the documentation first to add some more information. And then we can compile the documentation and visit it in a web browser. So I'll demo this to you. So let's go to, this is our step number 3. Okay, so I already have a documentation folder in here. I'm just going to delete it now. So now we have our project and no documentation yet. So the first step that I'm going to do is I'm going to call Sphinx -quick start. And it tells me, there's some introduction, and then it asks me, okay, what is the root path for the documentation? So where do you want to store the documentation files? And so typically I just use /doc in here, or /doc. So it's going to be in the folder doc. And then it asks me, do you want to install in a separate source or build directories? I just keep the defaults here. For most of the options, I just keep the default. It asks me for a project name. I will choose Monty Hall game here. Author name, just Simon. Project version doesn't matter, 0.0.1 in my case. Release doesn't matter. Project language. I just keep the defaults here. And then there's some add-ons, and so there's one add-on called APDoc, and it's an add-on to automatically insert doc strings for modules. And that one I'm actually interested in, so this one I answer with yes. Automatically test code snippets and doc test blocks. I don't need that. So most of the things I don't need, so I just deactivate them. Yeah. So I just clicked continue now, and then it asks me, do you want to create a make file? And here, again, just choose the default setting, yes and yes. So these will be the files that actually generate the documentation. And after I'm done with that, I now have a new directory called doc. And I can go in here, and you can see there's a few more files that were automatically generated. And so in particular, I can now type in make HTML, and that will now this will now compile the documentation for me. Okay, and it tells me the HTML pages are now built in _build/HTML. And I can open it. There's an index.html that I can call. And here we have our documentation page, which is at the moment quite empty. But you can already see there's some kind of, there's an index part here, a module part, and a search page. And for now, if I click on modules, it doesn't have any modules because I haven't told Sphinx yet which modules I want to document. So for this, I need to use the Sphinx -API doc command. So the way you do this is you type in Sphinx -API doc -o doc. So -o is the output directory because I have my documentations in the doc folder. I use -o doc here. And then the module that I want to document is called Monty Hall game. So I just provide the path of my module in here. And I run this, and it tells me it has created 2 new files, this Monty Hall game.rst and the modules.rst. And these are the files that will document now my modules. And I can run make HTML again. And hopefully now, if I clicked here on module index, so now I can see that I have indeed the documentation of one module, namely the Monty Hall game module. And I can click on it, and I get a nice documentation now for my module. And so one thing that I want to mention now is that, for example, here now the special syntax is interpreted correctly. So here I have returns is actually, in this case it's kind of highlighted and so on. And so there's also, for example, there's neat things where I can kind of just click on one. I can click on one function and I can ask to see its source code. So then immediately I can look on what is the implementation, and I can go back to the documentation. So then what else can you do? You can you have this index.rst in here, which at the moment is just fairly empty. But here's where you can add content for your main page. So I've prepared a little bit. Okay. So for example, let's just add something in here. This game implements this module implements the Monty Hall game. And then maybe you want to add an installation in here. You can add headers, install with pip install dot, maybe. Okay, so you add some content in here, and then you type in make HTML. It rebuilds the documentation for us. I can reload this page, go to the main page here, and you can see I now have these updated strings in here. So this is kind of how you would start building a simple web page for your project. And you can take these HTML pages now and just publish them on the internet, for example. Okay. Any questions so far? All clear? Okay, so what are the new files that we now have in our project folder? We have this doc underscore, and actually there's a bunch of files in here, but all of them are auto-generated. So we didn't have to do very much. So there's this conf.py, it's a Sphinx configuration file. There's index.rst, this we might want to edit because it contains the index, it contains the main page. There's make.bat and makefile, so these are the build scripts to build the documentation. And then there are the RST files for the modules. So just a list of modules and then my specific module that I want to have documented, montyhallgame.rst. Okay. So shall we do, maybe we'll just stop here and we start again in 10 past.